Hello,
Hello.
welcome back. I hope all are back from the break.
Okay.
Now the next session, that is the final session of the program, monitoring of persistent organic pollutants and support by Stockholm Convention Regional Center for Kuwait. The first talk will be Dr. Karel Martinez Guijaro. He will talk an assessment of POPs in the Oman environment. Now I am giving the floor to Dr. Karel. Dr. Karel, please go ahead.
Okay. Thank you very much for having me. So yeah, this presentation is going to be a bit short because we expected to have more results, more data, but we didn't have them. So at the moment, we're going to talk about the samples that we received in the lab. So we received 108 samples. 50 of these samples were belong to our regional project, and they were collected in Al Rasil and at Multaga location with passive samples. After that, we received another 58 samples that belonging to agricultural soils and landfill samples. These samples came to us through our regional center. So I don't want to extend me here, but it's like this. So let me see if I can just, yeah, here we go. So yeah, like I said, the first samples that we received here belong to the EM060AC project. This is a regional project that was run by.
Excuse me, Karel. Hello.
Yep.
Yes. I think your slides is not moving. Slides are not moving. So did you start to move the slides?
Yeah, I am in this. Which slides are you seeing?
Still, you are in the first slide. Your means like the first slide.
Okay.
And it's not in the presentation mode.
I have in the presentation mode my. Okay, let's see again. Let's start again.
Yeah.
So if do you see my screen now?
Yeah, it's visible now. So can you just scroll down the screen? Means the slides.
Okay. Now did it change?
No.
No. Wait a second. So that one you can see it, right?
Yeah. Cursor we can see it.
Now it's in the presentation.
Now
mode.
No. Can you just move to the next? Can you just move to the next slide?
Yeah, I did it. I'm doing.
No. Still, it is on the first slide.
Okay. So, but it's not in the presentation mode.
Yeah. Perfect now. No, perfect. It's moving now.
What do you mean perfect? For me, it's not perfect. It's not in the presentation.
Yeah, it's on the presentation mode. But maybe you can, let's say, minimize the top. Yeah, and then also take out the text below and then have it in that mode if you cannot really change in the presentation mode. So you make it as large as possible in this non-presentation mode.
Let me see. Do you see now?
Now it is in the second. Now it is in the second slide. So can you go back to? Can you go back to the first slide?
Okay.
Karel,
yes.
Would be nice if you do it all over again. Maybe there is some.
Okay. Let me start sharing my screen. I will start again.
Mm-hmm. Yes.
It's in the presentation mode now.
Now it is. Yeah.
Yeah.
Now,
Yes. Yes, super good,
moves to-
super good. Yeah, yeah.
Okay. So I was saying that we received in our lab 108 samples, that 50 of them belong to a regional project that was run by Dr. Bondi. And the next 58 samples, we received them later, and they were agricultural soils and landfill samples. Unfortunately, KISER is our institute. Sometimes is not ready to receive samples that don't belong to projects, but we have done our best to have as many results as possible for these samples. So if you look at this, this is the way that we register our samples. The first samples, like you see here, project ID, it belongs to the EM68 samples. Those are only passive samplers that we receive in our lab. So, and then after that, we start receiving soil samples, most of them from agricultural soils, the top layers of them, and then at the end also some landfill samples. Like here, we also receive some landfill samples. So the ambient air sampling, we couldn't. We did it through these passive samplers. These passive samplers, they are used in most of the studies in the world. The chamber dampen wind speed effects, protecting the sample from medium coarse particles, etc. And then this is the way that the way that they are deployed. So normally, before sending this puff, we pre-clean them depending on the target analyte. First with hexane DCM methanol for PFC analysis that we couldn't do here, but then we did a pre-clean with hexane DCM toluene for dioxins and dioxin-like PCBs, and then the same thing but without toluene or we can call them legacy POPs, but it's like for PCBs or CPBs, etc. Then after that, the POP were placed on in a desiccator, and then were sent to the different countries coded by color, so there is no confusion when deploying this sample, considering that the dioxin and dioxin-like PCBs we sent to POF because of the low level that we were expecting in this sample, so we sent to POF for them. So at the end, we normally try to do standard operating procedures. So this is in our lab when we approve them, and then we continue the analysis like this. The analytical methodology in general, this is a general slide. We collect the sample. It can be a POF like the one that I'm showing here, but also can be a soil. And then if we need some pre-treatment, we do this before, and then we spike our sample with the spiking extraction before extraction, and then we do the extraction. It can be in these cases in chocolate. We do what we did for all the samples that we have analyzed in this study. The analysis was done by accelerated solvent extraction, and after that we do a cleanup. This is the cleanup. For instance, this slide here is showing the power prep system. This is the cleanup for dioxin, but it also can be a manual system. That is the one that we use for legacy POPs. After that, and after the logic concentration step in between, we take the extract, the cleaned extract for any of the instrument we have in the lab, the LCM-SMS or the single quad or the triple quad or the high resolution system when we are talking about dioxins and dioxin-like PCBs. So normally, like I explained before, we run, we collect the samples, we spike it, and then we weight the samples and introduce it in a stainless steel cell, and we run this program in our Dionex 350 system. This is one of the many accelerators of extractors that are in the market. Most of the principles of all of them are the same, but this is the one we have. So then we have the extract. The message here is that the extract is not clean. Then it goes for cleanup and fractionation. So after we do this cleanup, in the case of the dioxin samples, because they are in case of air samples in general, because they are unique samples. So we normally split the extract in two parts, and then we keep one part of this extract and continue the analysis, the cleanup with the rest of with the remaining aliquot. So we're supposed to have the extract clean after the cleanup system when we add our recovery standards, and then this is an example for the dioxin and dioxin-like PCBs analysis. We analyze them in our AutoSpec Premier. This is our hard resolution system that we have in KISA. So let's talk about a bit of results. So I think our Omani colleagues, they already had the first table that they see here. So after this results, everything happened regarding COVID and everything, and now we could continue with analysis of these samples. These results are from last week and the beginning of this week in the case of dioxins. So when the workshop started, I was injecting the last batch of dioxin samples. But this is what we get. Like we expected. Those are not dioxin-like PCBs. Those are the regular PCBs. The concentration in general are very low. So we don't expect. We didn't expect a higher concentration here. Like you see, most of them are below the detection limit, and the range it didn't change from the beginning. I don't know if there was a decrease. Well, in Kuwait, and I don't know. I mean, all the world the activities in general were lower than before COVID time. So, and the concentration of all of these chemicals that we analyzed before and after COVID, in this case, we got a lower concentration. So we continue with the same PCBs in ambient air samples. So the sampling time in these cases, that also was affected by all this crisis. I mean, most of the sampling period was about from 70 to 90 days, but there was one period that was 140 days. This is also here because of everything what happened in this time. But again, the concentration are really low for these samples. So if we talk about OCPs, these samples, we couldn't finish them. We expect to inject them next week. They are extracted and cleaned up, but they are not injected yet. So we are talking about then the first set of data that we already submitted to our Omani colleagues, and well, like as you can see here, the mean concentration was 55 picogram cubic meters, and most frequently detected chemicals was para DDE, pentachlorobenzene, hexachlorobenzene, some lindanes, some para DDDs, and transnonachlor, cis-chlordane. Some few of them were detected. I will highlight the most important findings in this study. So DDT, for instance, the DDT ratio in Al-Rasil in June-September was 0.33, and Al-Multaga in September 2018 also suggests that there is fresh usage of DDT within the vicinity of the sampling location, because the ratio para DDE para DDT is less than 1. That is the criteria that suggests that there was a fresh usage in Oman in this time. So if we talk about lindane, this is here is the opposite situation. Normally in a technical mixture, the ratio alpha gamma is between 4 and 7. In this case, in Oman, we found 1.141, the average, and then the ratio between alpha and gamma range between 0.1 to 3.6 for the whole data set. This is in all Middle East, because this, like I said, this study belonged to the wider study where we collected samples from different countries. But in all countries, it seems that the lindane that we are detecting in our air samples belongs to, is originated from historical use of lindane. We also did a few analyses in agricultural soil. So again, like most of them are legacy chemicals. I'm pretty sure that most of them are not in use in this moment. And but yeah, we detected a few of them. Normally, para DDE, some hexachlorobenzene, but you have to understand that this is also an unintentional produced pop, that it might be originated from another source, like any combustion source or any other source. Also, some pentachlorobenzene somewhere here also, and then but most of the target analytes are not detected. Only you see some DDT metabolites, and this is what we have detected, that is in harmony with what we detected in air. Most of the chemicals that were detected in air, now we haven't here in soil, maybe deposition or any other cause. So we continue with these samples, the OCPs in agricultural soils. Again, the concentrations are also very low, but mainly, like I said before, metabolites of DDT or DDT, and some unintentional produced pop like hexachlorobenzene or pentachlorobenzene. So now we also did some analysis in PBDEs. So the first table, like I said before, this belonged to the first set of samples that we received. So the concentration here, most of the concentration that we found here are correspond to like rural or remote location, because they are pretty low. And most of the congeners that we are seeing here is mainly from the penta, and some deca congeners were also detected. but mainly PVD 99, 147. So those that belong to the penta technical formulation. And then let's talk about a bit about the dioxin results. The first, I think, yeah, these first 4 results belong to the first set of data that our Omani colleagues already had. But then we have added these results over here. These 2 locations, Al Rasil, according to the information that we have, there is still melting factory in the vicinity, and Al Multaga has some hospital or hazardous waste incinerator, one of it. So those are, when we compare these values with the data, the whole data set that we collected in the 068C project, those are the highest value in the region, and this is because of these sampling points are located close to these known sources of unintentional produced POPs. In this case, dioxins and furans. I'm just want to finish with dioxin like PCBs to see if we can see something else, and we are also trying to get a project when we will analyze PCNs, and I think I will also run this sample for PCNs in case, well, of course, hexachlorobenzene and pentachlorobenzene, but like the chemicals that we call that are listed in Annex C of the Stockholm Convention, we're going to run this extract for these oil chemicals, not only dioxin like PCBs and dioxin. So to put this in context, so according to a review report reported by Kevin Jones and Lohman, so they say that normally the remote sites we expect a concentration less than 10 femtogram ITQ per cubic meters, rural area 20 to 50, and urban and industrial area from 100 to 400 femtograms. Clearly, these values belong to a site where there is an industry there, and then I would like to confirm that this decrease in this concentration are due the decrease in the activity of this factory or something else, or maybe they improve the air cleaning system or whatever. But this is something that we would like to discuss with our Omani colleagues, or the people who collected these samples, if they have more information on this regard. So this is what this kind of a summary of what we got from all these samples in Al Rasil and Al Multaga. So with these 2 highest concentrations in 557 and 489 femtogram cubic meters during the sampling campaign of March-June 2018. So I would like to acknowledge this our funding agency, KFAS, and also Rodney, who helped us to execute this 068C project. And thank you for your attention.
Thank you, Dr. Karel. Now I think we can share the floor for the discussion.
Dr. Karel, thank you very much for your explanation, and
Okay.
your talk for the Oman results, but we would like to know if our results are in the range of the standards or high or lower than limits especially for the air ambient or air quality results.
Like I said, I don't know if Roland have more updated information, but like I said, there are not so really standards of the concentration of OCPs in air, so PBDs in air. Maybe I showed in my last one of the last slides the reference values that one of our top scientists in this field published a long time ago about the dioxin levels, but there is not a level like, for instance, in emission samples, we do have a level, but in air samples we don't have a concentration standard that we said we meet this standard or not. So so that's what I'm trying to say. There is no standard level. I don't know if somebody else.
But comparing with the other countries' results, if they are low or high, if I don't know from your experience.
Yeah, like I said, the dioxin values that were collected near these two industries, they are high, but they are not very high because they are. That's what we expect. So I'm sure if we go to these facilities and we collect an emission sample directly from the stack, we will see that these facilities are emitting an important amount of dioxins. That's what I expect. That's why these air samples in the vicinity are this high. But not, I mean, when you see other studies in, not now, because now since most of the at least in the developed countries, they have set up a set of standards that really toughen the standard. All these most of the emissions are lower than it used to be. But I remember when I was in Barcelona that we found a sample with 1,000 femtograms per cubic meter. So that was high. And there are some other countries that they have even higher concentration of these chemicals in air. But for instance, in case of OCPs, we don't expect them because they are not used in this moment. We are using newer pesticides, and those legacy pesticides we don't expect them. And in the case of PBDs, like our colleagues have said before, Dr. Roland, Dr. Sherin, so most urban sources are there, and it looks like this location where we collected those samples belong to industrial areas, not to urban sources. So we are that's why they are also lower. But like I said, is that there is no limit. There is no limit for this.
Yeah, exactly. Yes, but I think we are in the green level, not in the yellow or red level.
I think so. I mean, it's like I said, the industrial area. You go everywhere when you have
above 1,000 is high, but we are here low in Oman.
Yeah, I mean, for most of the chemicals, you are low, except this location. But again, so when, for instance, with this GAP study, they try to monitor remote areas, not industrial areas. So here in Kuwait,
maybe Dr. Karel, this maybe not coming from the contamination from the lab or not, you think?
Do you know if there is any hotspots in the nearby of this sampling location?
Sorry?
Do you know if there is any hotspot in the vicinity of this sampling location? Or for me, if I have a sampling point close to one of the main emitters of these chemicals, if the plant is not equipped with the best air control system, So if it is the case, I will expect that these levels are originated from a source that is close to the sampling point. So, but if you tell me, like I think we had a workshop here and we had a discussion with somebody from another country. I don't want to mention it, from another country, and they were not happy with the results, and they recognized that they had a hot spot in this area. So it's something that is, like Dr. Roland was saying, one of the things that is kind of compulsory for all these inventories is to find the hot spots. If you know that somebody was dumping some wastage in a place that with this weather here in this area in summer, they will re-evaporate them and then they will re-emit to the atmosphere. But if not, I will look straight into this steel melting plant or the hospital waste incinerator that you have over there, and that's what I would do to start. And I will compare profiles, and I didn't want it to enter here in details in profiles and whatever, but because sometimes you found like a mixed profile. It happened in another country. We got a high value, but we cannot identify we couldn't identify the source because it seems that the profile was mixed with like an industrial profile with an urban profile, and then we couldn't identify it. But the fact is that these values were higher than the normal ones, the one that I explained to you in this last slide.
Right, clear. Thank you very much, Dr. Karel.
Okay, thank you.